Welcome, everybody. A warm welcome to the last tutorial of the morning session of the last day of the IEEE CCM 2020 conference. We have with us Dave Nadgir, who's lead from the Singapore Singapore division of the Microsoft. He's the area technical lead there. Dave Nadgir leads the Microsoft Azure's data and artificial intelligence architecture projects for Asia Pacific region. He's passionate about technology and how it can help do the end-to-end business problem solving and simplify life. He has been a software professional for more than 20 years, a core developer, researcher, and architect across software products and projects. Welcome to you, Dave Nadgir. We look forward to hearing from you. The Limitless Analytics platform for data scientists and data engineers.
Okay, great. Thanks, Dr. Mohan. Hello, Dr. Shekhar. Can you guys hear me all right?
Yeah, perfect.
Okay, and you can also see my screen?
Yes.
Okay, great. All right. Okay, where should I begin? So first of all, good morning, and thanks for the opportunity. First of all,
good afternoon to you.
Yes, sir. Yeah, almost afternoon. Yeah. See, I'm going to make this quick, and this is a tutorial session across Limitless Analytics platform, and as Dr. Mohan introduced me, I'm one of the area architects based out of Singapore. I pretty much work mostly on customers who are niche across Asia Pacific, based out of Singapore. I recently, on personal reasons, had to travel a little bit to India and then to Middle East, and then just got back to Singapore in a quarantine hotel. As you can see, that's just me. It's not a robot speaking; it's the real person. So I just wanted to make sure that I share a bit of context. But we'll make this quick, right? The idea is, in my role, it's quite exciting in terms of being able to solve realistic problems with customers. And I also, in my extended capacity, work with product teams, which basically release different services on our cloud platform called Azure, right? I'm sure most of you would know what Azure is, AWS and Google Cloud. And Azure is Microsoft's cloud platform, like IBM's Bluemix, and so on and so forth. I like all of them, just to be candid. Now, for the past year or so, I've been working on this product called Azure Synapse Analytics, which is kind of quite exciting in terms of really simplifying this overall architecture in terms of how data engineers and data scientists come together to solve some of the bigger, badder problems that are related to data. Now, if you look at the overall theme this year for CCEM, you will realize that this conference is essentially revolving around data at a larger scope, and it's very evident that we are kind of really seeing a shift towards how data becomes very key to the overall cloud strategies that customers and large enterprises are adopting today. Now, I don't want to sound very pedagogic and kind of keep teaching, because the attention span on some of these are really about like 20-25 minutes. I just wanted to make it as interactive as possible. And feel free to just chime in here. Dr. Mohan, is there a way we can actually ask students to type in their questions or comments on the live chat, right?
Exactly. Yeah. In fact, I'd like to invite everybody to type in their questions on the question chat, and I'd like to request Dave to have a look at it, or perhaps we can read it out for him. And right now, there's no questions, and you can just go ahead.
Yeah, absolutely.
Right? You don't need to wait until the end for the questions. You can type the questions even as Dave is talking. Of course, it will be answered at the end.
Absolutely. Thanks, Dr. Mohan. Yeah. So make this interactive. I know that we have about like 25-30 people on. I'll be coming back to the chat window and checking. But then, so I want to kind of what I want to do really with about like half an hour or so is to kind of really look at what is this digital feedback loop and how limitless analytics is an important aspect today. Then we are going to go and define what does limitless essentially mean, and then kind of come really towards how do we establish the limitless analytics platform, keeping in context of the requirements by data scientists and data engineers, and really kind of bridge that gap, right? So this is a slide kind of markety, but essentially is very important to understand where data becomes the center of everything today, right? And it's growing at a phenomenal rate that's unprecedented in terms of what we are seeing with enterprises. Now, I work with customers across APAC, and it's so easy for customers to store data and never delete, right? And this is a trend that is making enterprises really deal with challenges with respect to data that is really, really unprecedented, right? So today, with an enterprise, it's very easy to see zettabytes of data that is just lying around. Now, somebody asked me, how many zeros in a zettabyte, right? Is there anyone who can take a shot? How many zeros in a zettabyte? 0 bytes. Who's going to answer first? I'm just kind of trying to keep this interactive.
Everybody has access to a laptop. Everybody has access to Google. So all that you do is speak and get the answer, steal the answer from there, and then present it to Dave.
Steal the answer and bring it up here. Let me wait for.
Guys, be smart.
5 seconds.
All right. Yeah. I think Dave, you should do the spoon feeding. Continue.
Yeah. Okay. No, that's all right. There you go, Rajat. Excellent, Rajat. Dr. Rajat. Okay. Excellent. So. 21 zeros. The important part here is when you kind of begin to look at such amounts of data, how do we deal with looking at that data, storing that data, processing that data at a higher level, at a holistic level, right? So these are kind of challenges that are really existing today with enterprises, right? So like Dr. Rajat very quickly figured out, right? If we need to process zettabytes and kind of really come up with like top 3 trends for a specific market, for a specific group of products, how do we kind of really process? And these are type of challenges that enterprises are addressing. And this is kind of a report that was taken recently. So the question is, how do we bridge this struggling silos, right? As you can see, that 55% of all of these projects really fail, and they still report that data silos and data management is a very big bottleneck across. And 80% of enterprises are still struggling to become mature at users of data, which is a very, very big challenge today. So all you entrepreneurs, I was looking at some of the submissions, great submissions, but then really looking at this data challenges, how do we kind of really look at bigger, better data problems? I think it's a real big problem. Now, how do we define limitless? The reason why these projects are failing is really across silos and limits in terms of how data is stored and processed. So in a sense, what we need to kind of begin with is defining what is a limitless. So in the context of analytics, limitless takes into account 3 key architectural components. One is the storage. This architecture should be distributed in a way that simple users can actually store any amount of data, like your C drive, D drive, or / data, if you're from the Linux world. So in a sense, it should have some kind of a namespace understanding, which essentially brings data at the core, right? And the second part is really compute, right? How data is persistent is great, but then can you process that data? Like I was saying about terabytes, zettabytes, they're all easy data sets that we are kind of really looking at today. And the third aspect is really being worldwide. what we're kind of really looking at here is there shouldn't be a limit in terms of, hey, you can access this data only here. You should be able to access this data set in this part of the region with regulatory specific aspects being taken care in that specific region, right? So this becomes a very big topic in itself. Now, if we kind of begin to kind of look at how do we bring this kind of a limitless platform for data scientists and data engineers, what we need to kind of really begin to look at is what are the key requirements in a sense to be able to look at these two specific personas within the organization. Now, this is kind of not limited. If you can see this particular slide, I've basically put together some of the requirements that are typically accessed or typically of concern or requirement for data scientists and data engineers on the right side, right? So let me see if there was any question there. I got a ping. All right, there's no question. All right, so at this stage, let me share a story, right? In terms of when I was visiting the chief digital officer in a bank in Thailand, and as you can see, banks are bound by lots of regulatory compliances. Now, one of the things that he said is both data engineering team and data scientist team reports into him under the cover. But then one of the things that he shared with me, which was quite eye-opening early last year, was he said half of my body it was funny to say body, but then that's Thailand. So to an extent, all due respect there, half of my body is already in jail. And the reason for that is I don't know who is accessing what. And this becomes a pretty big requirement for us to be able to comply with all the requirements that BOT is the regulatory authority in Thailand, the Bank of Thailand, which is basically governing what type of data access policies that we are implementing within the bank, and we need to report back, right? So you kind of get an idea in terms of data engineering teams having this data control up to the granularity of files, who is accessing what type, what file at what stage, right? So it's very, very important for data engineers to kind of really gain this control and really bring in different types of aspects of the auditing in terms of the data access. Now, there are various aspects. Engineering, from a data engineering aspect, I work with Grab. Grab Taxi is like the Ola in the region here. The kinds of data that we are looking at, the engineering teams that are kind of really looking at data and churning them is humongous. So clearly the limitless storage is absolutely a basic requirement today. Partitioning, it's a pretty big discussion in itself in terms of how we quickly partition data sets and how we bring in a specific schema understanding, which is actually dynamically changing as the data sets kind of grow, becomes another key important aspect here, right? From a data scientist standpoint, we need to be able to build data in a clean data set format and be able to look at that in a holistic way. And this is where the featureization and how we actually bring in machine learning models and take them through a pipeline becomes very, very important, right? So does it make sense so far? Yeah, so yep. I would take it a yes. So there are different types of requirements which I think is really, really important for a limitless platform, limitless analytics platform, which basically brings these two personas together. So in our endeavor at Azure has been to kind of really see how this analytics platform kind of comes and really makes this platform an easy to use kind of a set of products integrated together. So that has been our energy for the past year and a half, which I'm excited to show in a bit. So what does this essentially mean? So we defined a little bit of what is limitless is, but kind of really coming to the limitless analytics platform, when we kind of begin to bring the data professional of the next generation. So in a year, our purview has been that a lot of it between data scientists and data engineers are going to, the function within an enterprise is going to gray out. What that means is more and more data scientists are going to be data engineers who can really process a lot of data, clean the data, get to the feature sets very quickly using platforms, open source, obviously, in terms of Spark and so on and so forth, and be able to kind of homogeneously look at larger data sets, not really depending on a data engineering team. At the same time, data engineers who are really looking at data engineers who are more oriented towards SQL, more oriented large data sets, more oriented towards data preps, will look at data science and algorithms to be able to be very easily used. Obviously, they still are specialized platforms, but then if you kind of really look at this particular platform, these 6 or 7 kind of aspects around how we look at a unified experience, how we look at polyglot development. Polyglot essentially translates into I should be flexible enough to use different types of languages, be it R, be it Python, be it Scala, be it .NET, or be it Go, for instance, so on and so forth. Right? So lots of, from a data sciencey standpoint, SQL is another very, very important aspect. So how do we bring in that polyglot development environment? How do we enable collaboration across every individual being authenticated using their Active Directory or an LDAP identity, being able to be passed through seamlessly across different participating systems, right? MPP and SQL. So the reason why I kind of bring up this one is this is where the industry is essentially going, right? MPP stands for Massively Parallel Processing Systems. What MPP essentially brings out is this zettabytes and large amounts of data that we are looking at, along with new technologies like Spark coming together, kind of brings up the next generation of platforms. So when we kind of look at Limitless Analytics platform, we're really looking at all of these capabilities to be available in one integrated service. Now, Azure is a very big platform built on storage compute network, as you can see in the slide, very heavy slide. Don't bother looking at individual components. But the essence of this slide is there are so many products that can help you on Azure. I don't want to spend too much time. But then if you really look at this platform that existed today to data scientists and data engineers in terms of modern data pipelines, this is typically how we do it on Azure. Our friends at AWS and Google, they have very similar kind of an architecture. But then at a very high level, if you kind of really define what this platform does today in a very disconnected fashion, is being able to look at all of your data sources that you can see on the left here, and being able to connect them seamlessly through a homogeneous kind of a platform that can look at all of your data sources to be able to be imbibed into a limitless storage, right? So all of this essentially becomes a storage tier, which is aware of file system APIs, which means that you should be able to do a DFS LS kind of commands, but basically an ingestion, and then how do you prepare using Sparks, and then how do you serve using SQL, and how do you visualize? So Power BI is a visualization tool used by Microsoft, but then there are others like Click and whatnot, right? So there are all the other parts. Now, what we have been looking at is again, bringing together a simple platform here is to aggregate all of these aspects into one unified product set called Limitless Analytics Platform, which we call Synapse, right? So very excited about this, but again, lots of open source components. But let me try and kind of simplify this, or maybe more complicate this in a little more fashion in terms of what the architectural components are. Now, lots of things here. If you don't get anything, feel free to pause me and ask questions. Again, when we started looking at building out this architecture, first and foremost, it must have a data lake that essentially understands common data models. Again, CDM, common data models, as we can see over here, is very, very important for the next generation of analytics, which essentially translates into how you can define a semantic understanding of data right at the storage level, right? So that's common data models, all open source. Again, if you can search on GitHub on CDMs, you kind of get an idea in terms of what type of aspects are we looking at. Now, the lake, as we call it, is raw storage, right? In terms of you just keep dumping files, whether it's 1 MB, 1 terabyte, terabyte, and whatnot. That's not the point, but then it should grow seamlessly across, right? So that's the point that we're kind of really looking at over here, which we call Azure Data Lake Gen 2. Basically is nothing but a big drive. You just think of it as a big drive that doesn't end. But then, most importantly, what then happens is how do we bring together a consistent platform across being able to process all of this data that you're storing, be it text files, be it video files, be it audio files, and whatnot. But being able to process that, you need some kind of a platform that integrates across the Metastore, across monitoring, and across security and management, right? So it's super important that we kind of integrate all of this. If you worked on any of these kinds of platforms, you will kind of get an idea in terms of how complicated this can be. I spoke a little bit about runtimes in terms of what are the major runtimes that data scientists and data engineers are kind of looking at today. They can broadly be around SQL kind of platforms or Spark kind of platforms, right? Python and Spark and R. The Spark as a runtime kind of as we kind of begin to kind of look at establishing some of these platforms, it gave us form factors that can be very dedicated to a specific use case, which is where we are looking at a provisioned kind of a cluster that you can bring up, or you can bring up something called an on-demand or always running serverless kind of an infrastructure. I'll show you in a bit what that means. And then on top is really the polyglot development environment that enables the data scientists and data engineers to work together. Now, that essentially has to kind of really look at core features that this limitless analytics platform has to stand on top, right? And that has been our motivation at Synapse teams to kind of really make this as simple as possible for data scientists and data engineers to coherently exist and look at different problems. Now, again, if you kind of really look at the Synapse product in itself, it's a pretty big product in itself, but I want to kind of really look at just core features across 7 realms, which is around what I'm seeing here. But then let me make it quick. First is really performance. Let's deep dive a little bit into this, right? So performance is super important as we kind of look at more and more data. On the right-hand side of this slide is more marketed. You can ignore that. But essentially, if you're really building up this kind of a limitless data processing platform, you need an adaptive caching, which basically uses really new technologies like NVMe and technologies like FPGA from a networking standpoint, primarily because you're moving lots and lots of data across the participating nodes at very high speeds. So some of the stuff that we've been looking at in the architecture has been really how do we get this networking backbone and the caching backbone really right as we store large amounts of data that are moving across different nodes. Query optimization, again, very related to performance. How we kind of bring in different. I mean, if you kind of look at MPP, massively parallel processing as a concept. Dynamic query processing, or DQP as we call it, is a very important aspect of optimization techniques that are used across how different nodes participating optimize your query. So performance across these is a super important part. Now, Parquet, very important. Industry has decided that Parquet is kind of the open file format, very much supported by the open source community. Lots of really good teams that are participating in here, right? And some of the performance that we're kind of seeing with respect to some of the benchmarks as TPC Etch is very encouraging. So what we're kind of really looking at is can the new generation of data scientists and data engineers really store data sets relational, has a specific structure, but store them and look at Parquet as a fundamental dial tone to look at all of this data very quickly using Spark clusters. right? Are there any questions? Let me just quickly see.
There's a question from Rajat Vasudevamurthy.
Yeah, great.
Limitless storage seems a good thing at the outset, but what is the cost incurred for the same?
No, that's a great question, Rajat. So,
in fact, I'd like to add to that question and say, why do you use the word limitless? A lot of marketing zing bang in that, but not the technical part.
Yeah. So limitless. No, I agree with that. Limitless essentially stands primarily because there has to be no limits to how much amount of data you store and how much amount of compute you want to bring to process that data, right? So that's the reason why we are kind of looking at limitless as the fundamental term. Does it make sense, Dr. Mohan? In terms of, I've
I
been...
think you have enough resources to be able to accommodate the current needs. That's what you're saying.
Yes, absolutely. So, and it should be in a way that, it has to be limitless in a true sense that I should be charged based on amount of that I store, but I don't have any limits in terms of how much I should be storing, right? And so in some of the, I've been in the industry for 20 plus years, and if I had to be having the same conversations with, when I was part of IBM sometime back, and it was not just an IBM part, but then architecting a petascale storage in itself was a very complicated discussion altogether.
Right.
Today, that's not the case.
I just want to add, there's a very nice book called The Fourth Dimension, if I'm right, about data, written by one of the Microsoft Research, distinguished fellows.
Yeah.
And there we talk about how astronomy needs, zetascale, petascale support, for which there's this existing cloud architectures being very, very limited. So I want to ask you in that sense, where does limitless come into picture?
Yeah, so the limitless essentially comes in the point of view of the architecture that we have at the back end is completely managed by us, is transparent to the end user or the cloud user, but from their point they don't see any limits, right? So as an end user, I don't see any limits. I can keep storing. At the back end, this is where Azure teams, like the team that I belong to, we store, scale, and manage that particular cluster behind the scenes, completely transparent to the end user.
Do you think that, I have a question here.
Yeah.
Do you think that recently, I'm sure you must have also read about this, the first proper black hole, what should I say, imaging took place by a scientist who led a team of people from across 7 astronomical centers across the world. She's from MIT, and they used to work with hard disks being shipped around. So how do you, what do you think about your alternative as a limitless thing, which she should possibly have used and Microsoft should have possibly supported?
That's a great question, Dr. Mohan. Yeah, so I guess, in the context of edge computing, I think this still becomes a kind of a limited fashion. But if she had used probably a cloud kind of a solution, it would have been a very easy step-by-step process for her to store any amount of data today.
Okay.
But yeah, edge, I think, continues to have that particular challenge.
Okay, so what you're saying is that businesses can really grow up without really wondering about lack of availability of compute power on the cloud.
Compute power or storage limits on the cloud. Yeah. So this thing is changing so fast, and there are also concepts in terms of blob as a distributed storage technology. Right. Now that has actually evolved to having file system aware storage systems. What that means is I can actually get a file pointer to a specific file in the new architecture, which means that I can actually store a file system based. I can actually look up that particular file in a way that I can really do a LS or mount that specific file system on any other supported type of hardware, which basically brings in an API tier to kind of convert your distributed blob into an actual file system, right? So that's kind of quite exciting in the new architectures. Now, quickly to the point that Rajat has here in terms of limitless storage seems a good thing. for the outset, but what is the cost incurred? So I think that's a great point, primarily because what we're really looking at is delineating between compute and storage. And storage comes at a very cheap cost, right? It's so cheap that customers or anybody is not worrying in terms of storing data today in the cloud. Whether you store petabytes or zettabytes, storage, once persisted, kind of lives in the cloud, distributed, managed by a cloud provider like Azure, Google, AWS. But the storage cost is very, very less. Cost comes when you begin to process it, and that is where all of these aspects that I was kind of looking at on the slide kind of comes in, where you bring in new clusters, you bring in queryability and optimizability into the equation. So cost, as far as storage is concerned, is still less. You optimize the cost by bringing in these dynamic processing cluster as and when you just need. Just to give an example, across Philippines, Union Bank and others, when we're kind of working with, their morning report takes about an hour and a half. And that is only where compute clusters actually come in, generate the reports for all the branches, distribute them, and shut down. Right? So that is how the optimization of cost in terms of processing essentially works. Whereas the cost of really storing all of these transactional data from banks, different branches of the banks, is very very cheap and is always persistent. I hope that makes sense, Rajat.
Yeah.
All right. So, the aspect of SQL and MPP, again, I want to kind of make it very, very quick here, but then SQL is an important part. And all of these aspects in terms of how do you basically hash distribute your data as you store it, and how do you bring in different caching technologies and materialized views is again a very important aspect. Again, I just don't want to, these are aspects that are part of the Limitless platform as you begin to look at aggregating data at a holistic level. For example, the example that I gave in terms of, how do I generate a report for every branch in the morning in 1.5 hours? So, that needs indexing, that needs column level, and then brings up parts. Now, this is an interesting slide, which is, I'm going to show you an example of this in a bit. But what we're really seeing is, can data stored in raw format being accessed in SQL format, can we really bring in a model, a machine learning model, to SQL at scale, right? So this is a recent work that we did. In a sense, what this translates to translates into is when I begin to kind of look at select statements, I can bring a very native predicate to invoke models using just a SQL statement. So as you can see over here, if you kind of double click on this specific statement, you're kind of looking at all the inputs of the table into a model, and we can get the score from the result set of the model right in a SQL statement, right? So this is something that's pretty unique. Onyx is open neural network exchange kind of a format where we're looking at all the industry leads are kind of coming together. Facebook, Google, us, IBM, so on and so forth. All big players are coming to agree with how interoperable models are an important aspect, and how Onyx kind of is being defined as we speak. So again, a very important aspect for data engineers and data scientists to kind of consider. Again, security and being able to look at data at ingestion is an important part. But then this is another part. In a limitless analytics platform, when we begin to look at how do we process all of this data, we don't have endless cost, right? So there has to be some way, like Dr. Rajat, you said, and Dr. Mohan, you brought up, in terms of being able to give this compute into a cost-effective way of processing data. We need workload management, which means that I should be able to scale across teams in terms of how much of cluster that I should be giving, right? So workload management becomes, workload isolation and management becomes another very, very key aspect of the architecture in a way, right? Spark. If if you kind of know anything about data science today, Spark is something that you cannot miss. Spark is emerging very quickly and has a bit of a history. I just don't want to spend too much time here, but for those who kind of don't know, my background also goes back into distributed systems on HDFS, but Hadoop literally kind of got in this architecture, which was very I/O intensive across hard disks. Now that worked really well because those hard disks were available, were going into a very commodity space very quickly, and then it was also very intensive in terms of it was kind of cheaper in that sense. But today, that performance is something that is expected very differently. So Spark essentially rewrote that entire logic of MapReduce into in-memory based jobs, right? Which basically minimized writing into physical disks, and thereby seeing up to 10 to 100%, 100x faster architecture. So what we are kind of looking at this Limitless platform is, can we bring in ephemeral set of compute as and when we require them into a cluster, and make it available for end users and charge them back only as long as they run within as long as they run during the time of processing. And this is where, again, the cost becomes a very important aspect. So what we do here is, again, very open source oriented at the back end in terms of being able to look at Apache Livy project, if you guys have seen, but then think of them as super simple way to kind of request a cluster. You get a cluster, and then you can process it, and then you get rid of it, and you're not charged anything for it, right? So simple to understand, but then Spark becomes a very important aspect. Orchestration. So ingestion is an important aspect of really doing anything with analytics. If I cannot connect to my source data and get that data for my analytics purposes, I cannot do anything. So what we're really looking at is an ingestion kind of an integration platform that comes within the platform to be able to connect to 70 plus data sources that we are already aware of. Again, this becomes a little more clear when I show you a demo. But then think of it as orchestration is nothing but being able to connect to your source data sets and be able to get that data. Right? So this is kind of a quick overview in terms of where all can you connect. Again, different products, different providers have different products out there, right? Visualization. This is where we have kind of seen lots of interest for data scientists and data engineers, and bringing business analysts into the equation. Being able to look at your data, visualize your data on demand, and be able to collaborate on this aspect is another important aspect. Not going to spend too much time on monitoring and management, but then in a sense is everything becomes a compliant question by the end of it. What have you run? Where have you run? Who has access to what data? So very important for all of those aspects to be available within the platform. Now, security. This is where I spend a lot of time in my interactions with customers, where how do you secure all of this data individually at a file level, but granularly at a data set level, right? So this becomes a very big conversation in itself, and being able to look at how do I define ACL, or access control lists, or role-based access controls, or RBAC as the industry kind of calls it. Becomes an important aspect, again, to look at different compliance. And before you host an actual solution, for example, HSBC, when we were kind of working with some of these compliances, are super important to be able to kind of look at. Does it make sense so far? Anybody has any thoughts, comments? Makes sense? Doesn't make sense? Would love to hear feedback.
Yeah. Any questions, please?
All right. Yeah, let me keep moving, but then as it comes.
Ambati has a question.
Yes. Yes, sir. Yeah.
The data we are talking here is relational data, but all the real world need not be relational always.
Correct.
What tools we use on Azure to process voluminous real world non-relational data?
Yeah, excellent question. Was that Shashikant? Yeah, great.
Yeah.
Yeah, so no, that's a good point. So this is where relational view into a data is important, but then not all the data is relational. Like you said, there is SQL data, which is probably representing your tables and relationship with tables, and there is big data, which represents maybe just simple JSON files, right? So, but there is some level of structure or semi-structure to JSON files that are, for example, or Parquet files that you store, but you can bring in schema flexibility to be able to represent and look at that data in a different format, right? So that's the second type of data. When we kind of look at this type of data, we really look at processing using Spark, or look at that specific Parquet, for example, Parquet set of files that you store on your file system to define a schema, or schema-free is another part, and look at representing that data in a SQL fashion or in a row and column fashion by understanding the schema within that semi-structure, right? The third type of data is really video and text and so on and so forth. That essentially is handled very differently. You need different kind of compute. So, for instance, if you're kind of really looking at massive video processing, there are other types of video encoding and decoding technologies that we need to rely on. But from a big data analytics standpoint, Spark and being able to look at Parquet and Parquet processors in a semi-structured way, that becomes an important second way of really dealing with this data, Shashikant. But yeah, great question. All right. Again, I mean, feel free to ping me on this one, or in my mail, or on Twitter. We can have further conversation in terms of what type of data that you're kind of looking at. But broadly, those are the two aspects. Now it becomes more and more interesting when customers begin to store all of this data limitlessly. How do you discover, what type of data is there in this, say, for example, folder structure that I'm storing all my transactions? Can I automatically discover type of data that is available and being able to look at, hey, can I find out that there is PII information that you're storing here without your own knowledge? Becomes a very, very key aspect in terms of being able to look at this. So if you look at on GitHub, if you search for a project called Presidio, let me just type in here. Presidio kind of brings in a very cool way to really look at different types of patterns within the data and kind of extrapolate that into something that you can actually classify as, let's say, PII, or personally identified information, right? Super, super important aspect, especially when we begin to look at enterprise patterns, right? So network level, again, I don't want to go too deep into this, but then that essentially is something that I had in mind to kind of share. Again, I think we've already spoken about like 59 minutes, but I wanted to kind of really quickly show you a simple demo that essentially brings these aspects together, right? The scenario is very simple here. What we are looking at is an SAP data. Again, I just wanted to make this more realistic to a business scenario as opposed to an innovation scenario. And these are some things that customers today run in production on this particular platform, as I was saying. So the idea is, can I look at all of these purchase orders that are going on? Typically, it exists in a bigger system within the enterprise, ERP systems, and SAP is the leader there, clearly. And can I look at all these purchase orders and give it to analytics team where there are data scientists and data engineers who can actually make some sense out of this, right? So, and the scenario that we're kind of looking at is, obviously, I need to first look at the data being ingested. So I need to be able to connect. I need to store this data in different formats. Again, this is where the limitless storage kind of comes into picture. And then I need to be able to develop views, develop point of views and analytics on top of this data that is now getting stored from your source systems, right? And there are different techniques out here, and obviously there has to be a monitoring, management, and security, and so on and so forth that I spoke. Now, let me just switch back here and if you kind of look at Azure, for people who don't know Azure, if you go to, you can actually get a free $200 per month type of a subscription, is what I understand. So I have lots of resources here, but if you get access to an Azure type of a platform, search for Azure Synapse. This is all live, so take it in that spirit if something doesn't work. But yeah, so in the sense of really creating a workspace for this limitless analytics platform, it's very simple. You basically end up adding a workspace, and essentially you get started with a workspace. Now, again, I just don't want to go into too much of details in terms of how do you create it, but it's actually very simple. You give it a name. You say which particular data storage at the back end you want to kind of use, and you kind of get something like this one, right? When you launch a workspace, what we're basically looking at from the scenario that I was showing over here is to be able to look at the source data and be able to store that data into a disk or into a storage data lake that gives you limitless capacity, right? So if I kind of look at the first part, which is really the data integration, we can begin to kind of look at pipelines, as we call it. Now, these pipelines are essentially very simple. All we're doing here is kind of connect to a source, and as we connect to a source, in this case, this is really an SAP kind of a data source that I'm connecting to. I can basically look at this POs, purchase orders. I'm basically downloading all of these data transactions in a way that I can actually look at incremental data sets, but I can connect to a lot of other types of data sources, right? So this is where the integration requirement for the analytics platform, that when you kind of really look at how do I store all of this data, you really have to look at your source systems, right? So sometimes this is just transactional databases, sometimes this is other types of cloud storages, or other types of simple facets that are represented across, right? So what you're seeing over here is 70 plus, 90 plus, as they call it. Integration into some of these data sets are important, right? Now, it's not just about integrating into a source system, but it's also important to kind of really look at how do you enhance this data within the analytics platform, right? So what that means is, when I begin to look at this table, SAP table, and storing it into, let's say, a set of files as purchase orders, I need to be able to combine that into different types of fashions, right? So here is where I'm kind of very simply showing a part where I can bring in a supplier information. So purchase orders is where company goes and buys something, right? And then there is an invoice to this, and they're all audited on it, right? But can I get some more information added from a supplier table and do some really cool pivoting, for example, or do left inner joins, right inner joins, and right outer joins, and so on and so forth, to be able to arrive at more cleaner data. So this is what I refer to as the integration hub, right? So if we kind of switch back over here, what we looked at is we built a pipeline, and we stored this in the data that we are seeing in the source system into some raw files. Now, so when I kind of really look at all of this data store, and this is where the data hub kind of comes into picture. And as I was telling earlier, when we look at data storage, there are different types of storage systems that we can look at, but then this limitless storage essentially comes into the point where we are storing source system data in simple file formats, right? So as I can browse through this set of files, what you can see is my files, my purchase orders, are simply a bunch of files that are right now looked at by, let's say, a CSV format, right? So this is where one of the questions around is there structured structured part to all of this. I mean, in this scenario, this is like the table that we are looking at, so there is a certain structure. But then I should be able to really quickly connect to that specific file that I'm storing on my storage is a very immediate connect, right? So this is where I guess being able to connect from a data engineering standpoint in terms of what this data essentially means is an important aspect. In a bit more detail in terms of, can I quickly query this, for instance, right? I mean, this is just a file that we are storing, and look at.
I think, Dave, you need to share your screen. You lost the screen.
Yeah. Sorry, are you still able to see me, Dr. Mohan?
Yeah, I can see you. Your video feed is fine.
Not the presentation? Is that all right now?
Yeah, the presentation is not there.
I see. Okay, so let me just reshare back. Dr. Mohan, is that all right now? Are you able to see?
Yeah.
Okay, great. Yeah. So what I was showing was, to be able to very quickly generate any views on this one and bring a structuredness into this. Again, SQL becomes a kind of a language that everybody is used to, right? I mean, the kind of knowledge that is there in here is phenomenal, and we wanted to kind of really look at a serverless way of really executing SQL on actual files. So as you can see this, I'm executing a simple SQL statement on the file that I got from my SAP system, and I don't have any infrastructure whatsoever. This is like executing a query on the file, right? So SQL becomes kind of a very important aspect to kind of look at. Now, SQL also brings in a lot of interesting aspect in terms of querying data in Parquet format, for example. If I kind of look at Parquet as a stored set of files, these are other ways. Like I think Shrikant also had that particular point in terms of can I bring in what type of technologies can I bring in to look at Parquet as a semi-structured set of data that I can process, right? Again, open row set are ways of really doing this in SQL today. But then again, Spark is another way that we're seeing more and more. Now, from a data scientist and data engineering standpoint, what becomes important is to kind of look at all of this data in a holistic way, right? And as an engineer, as a scientist, I should be able to first be able to look at all of this data at scale, one. Two, then I also should be able to build models and collaborate on these models with other colleagues at the same time. So this is where the developer hub from my earlier demo kind of comes in over here, where we are looking at, we stored the data at scale, again, be able to look at now looking at really writing some scripts and notebooks to be able to make sense out of all of this data. So let me just show you a couple of examples. This can really be a longer topic, but in a sense, as I begin to define different types of schema, I can complicate or I can extend my my data sets in different ways. As you can see over here, this is a very simple aggregation that I'm running on about whatever 181 million kind of net parts here, but being able to really look at look at different aggregations and look at different groups within SQL, right? So this is one part. The second part, from a data engineering standpoint, again, what is very important is to be able to use Spark for preparing your data. Now, this is where 80% of the effort essentially kind of goes in, even in being able to look at a simple project. What I wanted to show here is PO Explore and Convert. I guess this will be a good example, right? All I'm kind of trying to do here is look at the data, understand the data in different dimensions, right? Like, for example, all the fields that I had, how many uniques are there? What type of data are we missing? Can I just visualize very quickly? Now, what's important here is even on a semi-structured nature of the data, can I bring in SQL through Spark Metastore, right? And again, this needs a bit more understanding of the data frames and how Spark views are being created on top of Spark data frames. All I'm kind of trying to show here is if you look at the same data that I showed, which is like in a tabular fashion, a Spark cluster can come and define a view on top of which you can process it. Now, this is where, to Dr. Rajat and Dr. Mohan's point on how do you optimize cost, right? Unless I bring up this particular cluster to process, I'm not incurring any processing cost here. The storage cost is cheaper and it's kind of always stored, right? And now what I can do is to bring in SQL. If I'm a data engineer who's more comfortable with SQL, then I use SQL. If I'm an engineer that uses more Spark or Python or Scala, those are aspects that you need to be able to use across some of these polyglot way of really development in the platform, right? Now, the scenario that I'm kind of showing over here is, Parquet again becomes a very industry accepted kind of format. What I've seen data engineers do more and more is explore these types of data sets and store the data in a way that that is consumable across different types of teams using formats like Parquet, right? So what I'm kind of trying to show over here is, again, I'm writing a very simple partition, but I'm writing into my storage back and Parquet_data mart in a format called Parquet. So which essentially translates into, I now have my SAP data stored as my Parquet table, set of Parquet tables that I can actually define using a very simple format, right? So a data engineer's job kind of comes over here, where I have my source data. I may be connecting to, as we speak, I'm working with the financial services company in Malaysia. 6 terabytes is one table. So you can imagine the kind of look at kind of points that we're looking at. Now, the other part that that I want to, again, I'm sensitive of the time here. Dr. Mohan, how much time do I have? Do I have another 5 minutes, 10 minutes? Yeah. Okay. Great. Yeah.
You have another 10 minutes.
Great.
No problem.
Thank you, sir. Yeah. So what we are looking at over here is a data scientist now coming in, right? So now this is a part where we are looking at, can I access my raw data? Can I look at building a prediction kind of a problem here, right? What we want to predict, we want to predict the amount of tax, for example. I mean, this could be just a very simple sample, but then you kind of get an idea in terms of, by the end of it, there is a target column that we are kind of really trying to look at from the past historical data and kind of bringing different types of models to assess what type of model fits better for this tax amount that we are looking at. Now, if you're a data scientist, you probably know what I'm talking about. But if you think of it as a very simple connotation of really preparing your data, cleaning your data, and applying a set of algorithms. Now, I'm going to skip some part of the data prep bits and pieces, but then you can apply different models here, right? So to an extent, I've kind of used again simple PySpark-based ML libraries, and then look at ML Flow as another open source, very industry accepted kind of a model management kind of a platform that Azure kind of supports. But apply basic algorithms, right? Because we're kind of really looking at a prediction kind of a regression kind of a problem here. We're looking at linear regression, GLR, decision trees, random forests, one of my favorites, GBD, again, one of my favorites in terms of some of the regression problems that we can look at. But then by the end of it, as you can see, a data scientist on the same platform is now able to bring in ML libraries to look at that data at scale. Again, all of this is secure in terms of fundamentally identify who is accessing what data using the identity. Like at this stage, I'm logged in as Dave Nadgir, but whatever I'm doing is completely logged, audited at this stage, right? Again, I don't want to kind of teach data science here, but then you kind of get an idea in terms of if I'm able to look at my training data sets and validation data sets, I'm able to now look at fitting different models and saving those models and comparing those models within one notebook. And these are notebooks that are available as such, right? Now, again, this is a very simple part where I'm also looking at, hey, for this particular currency, if this is a gross amount and these are the taxes that we're kind of looking at, what are the types of predicted scores based on my linear regression or GLRs or decision trees or some of the GBTs that we kind of applied, right? So this is just more of exploration in terms of how to apply using different polyglot environments into building a model that I've already stored, building a model based on the data that I've stored, right? Make sense so far? Again, so in terms of dial tone of data set, predicted values are also scored and created as a set of data sets that are available for everybody to kind of access. And this is where, again, I'm kind of really looking at very simple, partition. I don't want to complicate the partitioning story here. But then if I look at my scored data, so these are all predicted values that I can actually run, for example, every day in the morning, go for prediction pipelines, look at my data, prep them, build my models, score them, and then store them back into a particular folder structure out here. And this is where the story of the Spark cluster kind of ends, right? What that means is if you kind of go back to purchase orders and Parquet ML score data, you get an idea on the data sets that I was talking here on purchase orders. So when my when my pipeline on machine learning models essentially runs, all I'm making is I'm getting my data sets on score data for Parquet. I'm storing my score data on both Parquet as well as CSVs for the scenario, but then you get an idea in terms of how Parquet becomes super important. Now, in terms of being able to productionize some of these models, what we're looking at is how do I visualize different types of data using simple Power BIs, right? So that is where some of the develop aspects on Power BI kind of becomes very important. Again, this is as I store more and more data, I should be able to give that data for business analysts or data engineers, again, to kind of really look at this analytics at a scale. All we are trying to do here is, as you store your data, you should be able to look at look at your data sets and be able to give that to your specific connected Power BI or connected visualization stores, right? Again, this kind of connects back into your storage tiers. And this is where if I kind of switch back to how do I develop some of the visualizations inside a particular platform, this is where Power BI comes integrated into one kind of an experience, which was one of the requirements that we defined earlier in the presentation, which basically translates into, can I have a ubiquitous way to kind of access all of this and be able to visualize? Now, these are just examples. I don't want to kind of give a view on some of these fancy stores here, but then you get an idea in terms of, can I very quickly look at building a new, for example, a new, let's say, a pie chart, and you kind of look at some of our data marts that we actually looked at, and build these types of graphs right in a UI, collaborate with others, and be able to publish as and when I have new reports, right? So that you kind of get an idea in terms of the visualization part. Now the monitoring and manage, I'm going to skip that, but then one of the important or rather interesting aspects today, how we are looking at bringing machine learning into the data engineers world today is around how can we enhance the predict algorithms that I just showed. I'm just going to take a different kind of an example over here where I've stored a simple table where there are different taxi rides that are happening. But then if you kind of look at, this basically stores, let me just show you that that column just in case you get an idea on what is happening here. So it executed this query. What it's showing is on data that is storing trip information from New York taxis, whether you got tipped or not. So the problem that we are trying to solve here is, again, a simple binary classification kind of a problem, machine learning problem. But then can I really look at enhancing this table or creating a new table using machine learning? So what we are looking at here is connecting into a machine learning kind of a workspace, again natively connected, and be able to kind of really look at choosing a model that can help me predict tip amount, for instance, whether I'll get tipped or not. As a very simple example, but then what I'm basically trying to show here is machine learning, as you build your models and store your models, you should be able to very quickly access those models onto your system of records as you store in your tables, right? So this is a very simple example. This is basically to kind of give you an idea on if I have a model that I've already developed for my particular table, I can actually look at using that model, giving all of this table data into that model and getting an output at scale. At scale is the underlying part here. I'll say test as a stored procedure. I'll create a new table. I'll not get this thing messed up. All I'm trying to do here is I'm trying to execute a model at scale on a SQL data that I've stored as tables, but then apply a regression model, in this case, binary classification model, using a predict method across all the tables. So let me just give this table as test tip, right? Right. Test tip. So if I kind of really look at deploying a model, we convert these types of, so the model that I used was a very simple scikit-learn kind of a model, but I can now convert that model into an ONNX format and be able to look at applying that model to a specific table that I've deployed within, right? So this gives you kind of an idea in terms of, you start looking at your data at scale. As you can see over here, this is output label, which is a predicted value from the from the model that we had deployed. We use that on the rows that we selected. So this is just a very simple way. But then, if you kind of really know, in bigger organizations, this is a very, very powerful way to operationalize your machine learning models very quickly, right? So that kind of gives you an idea how data engineers and data scientists can actually work together to not just build the model, but then operationalize it very quickly, even at a simple fundamental data store, right? So that's pretty much kind of covers this particular aspect. That's pretty much what I had in mind to kind of show. So with that, are there any other questions?
Yeah, there are a couple of questions that got answered. I think you kind of answered it. How can Azure Synapse be used for edge analytics? That's a question from AM.
Okay, excellent. Yeah, AM, that's a great question. So edge, so let's define a little bit of edge, right? So in the context of edge, edge is where you're closer to where data is getting generated. For example, an IoT kind of a scenario is a very powerful connotation there, right? What we're looking at is imbibing all of this data from an analytic standpoint at scale using simple messaging as a fundamental way to represent your data. So today, the scenario, for example, the part that I was working with a telco in Australia was around CDR data, right? So call data records. All of these call data records essentially gets processed by edge devices, but then at the same time, as and when the edge essentially persists the CDR data, there is an event sent in a Kafka format into a so-called event hub or a Kafka topic. That Kafka topic essentially persists back as simple JSON event file in the data lake storage. So this is where these are the kind of patterns that we are looking at for edge. So in a way, Synapse becomes a big data MPP kind of an engine in the cloud. But on the edge, what we need to really look at is how do I apply a specific, either a scoring model on the edge device, and most importantly, how do I take the data in a very simple format using messaging as a kind of a pattern in an asynchronous way, and store that message into the storage architecture that basically scales on its own. Does it make sense? Yeah.
Okay. Yep.
Excellent.
All right. There's another question from Ram Babu, and he's also located in Singapore.
Hey, Ram.
The question is, the data we are talking about here is relational data, but all the real world needs not be in relational. What tools we use on Azure? What tools can we use on Azure to process voluminous real-world non-relational data?
No, absolutely. So I think that's a great point, Ram. I think we discussed briefly before. Again, so there is a semi-structuredness to real-world data, right? So SQL, trust me, this is still a very, very big part of the organizational data, enterprise data that we are looking at. But then the moment we kind of look at schema-less representation of data sets today, that schema variation kind of brings into Parquet as a format. So this is where Spark kind of comes in to picture, where we're processing different Spark data frames with schema variations, where you don't have a specific schema for like how we have in relational data. So when you don't have a specific schema, we need to kind of begin to look at schema-less or flexible schema processing for representing your data. Now, there are different techniques as we look. I'm working with again, a financial services based out of Singapore. What we are looking at is when we look at this different type of schema as we process the app data. So this is the scenario is, there are 7 million users that access this particular app, but the app usage data is different every time. So what we're really looking at is process that data using Spark, look at flattening that data in big Spark clusters, and storing the flattened data back into the data lakes in a processed format, and then further process it. Right. So that's one technique in terms of semi-structured or schema variation based data sets. The other part really is, completely unstructured, right? I mean, just like text files, for instance. I need to be able to look at text files, look at video files, make some sense out of text and video files, and then process that data further at scale. Again, this is something where depends on the scenarios. For example, reading text, or reading video files, reading PDFs, so on and so forth, you need to still be able to look at holistically and be able to bring a certain metadata within that data set to be able to process. So that's the third type of technologies where search and cognitive services that we have kind of gets applied. But yeah, I'm glad to see that question. I mean, if there is a specific scenario that I can double click, glad to be of help.
Okay.
All right.
Thanks a lot. I think there are there any more questions? I for sure was actually going through the minute details of your screen presentations, trying to understand how you are essentially, what kind of features exist in your Synapse tool, right? And it was a nice presentation. So Dave, if nobody else has question, I think it's important for us to say a big thank you to you.
All right, thanks, sir.
I think it's a wonderful presentation, and unfortunately, while not many are there to hear you in live, at least they were. These videos will be recorded and hopefully will be used by folks to understand how to do a lot of analytics on the Azure and the kind of things that you said you can do with Presidio. I went and checked out the GitHub and it looks very interesting there. So on behalf of CCM, IEEE, CCM, the organizing team, we'd like to extend a big warm thanks to you and a big round of applause. You see a lot of bubbles floating up.
Thank you.
A lot of we call emojis there. Okay, be in touch and it will be great.
Thank you, sir.
Okay.
Thank you. Thank you, Dr. Mohan. Thanks, everyone.
So, thank you, Dave.
Thank you, Dave.
Thanks.
So we come to the end of this tutorial session. I'd like to request our host, Shashi, to end the session and start another session because we need to have a small research student symposium demo for 10 minutes. After that, we'll close off. Okay? Pankaj from Chandigarh is going to do the demo. This was a request, and I thought we can just do it.
Dr. Mohan, is that where Mr. Pankaj sessions comes in, or?
No, there's no separate session.
A couple of minutes. I'll create a session now.
And meanwhile, Dave, have a safe time